Hello everyone, hope you guys are doing well. So today we will be continuing with where we left off with Swift. So the last time we learned about optional. So optional is a value is something which may or may not contain a value. So there are three ways of accessing an optional. So first is using if let. Then is using nil coalesce. Nil coalescing is basically adding a value using double question marks. Then optional chaining is when that can be used on methods. So if the value is nil on the left hand side, then the entire value will become nil. Now let's move on to enumeration. So enumeration is basically so as I said, the literal meaning of enumeration is the action of mentioning a number of things one by one. So for example, what if this string could be anything, right? So then this check will not survive. So will not be a proper way to do it. So if this weather could be rainy, sun, it could be anything. So when we pass this value, this can be any value, right? So then what we can do using enumeration, we can group. Enumeration basically helps us to list down all possible values of that particular value. So then let's see this example. Then now here if I'm going to check if the weather is sunny, then I'm going to do, oh, this is a string. Strings are always in double quotes. This is going to be sunny, and then I'm going to do something, say I'm going to print. Remember this has to return something. It will be returning a string or null. So here it is returning a nil. And then this is else. This is an optional, or like this is not mandatory. Every year it did not have a. Now see, this is okay. Right now we have, okay. This will be invalid read it. Oh, so there should be there will be another function. Let's let's make this let's add a number 3 or something at the end. Okay. Another function that types a string defines the current weather. The problem is a string is a poor choice for that kind of data. It can be rainy, sunny, or raining, or showering, drizzly, or stormy. In the worst, that what if a person writes rain with an uppercase R? So that's what I'm trying to say. Let's put it into code. Now, enum is basically listing down all possible types of a given variable. So then I come here, write enum. So then I'm going to say enum. So enum, the syntax is enum, then weather type, then we declare a block of, and then we write case. Yes, and then we do all possible values. So it can be case sun, it can be cloudy, it can be wind, or it can be no. Now okay. Now when we are going to call this function, what we are going to do is I guess this needs to be a take a look of that type. This is what you will use in place of string or int line to define the 5 possible cases for enum. As I already outlined, convention as the start with the lowercase, so sun, cloud, etc. and line 3 is closing brace. Now take a look at what is used. I modified the get header status so that it takes so this has to be verified. This has to change right now. Previously this was striking a weather. Okay, and now so the type of this enum will be a weather type. So let's change this to let's change the type and make this as weather type. Now referencing operator on string protocol. This is okay. Let's see that further. So then now instead of weather here we need to do something like weather type dot cloud. Now go back and read the code again, because I'm able to rewrite it with two changes that are important, all set. But case sun, case cloud, case rain, case wind, case snow. Now what he's doing is, I made to this first. Each of the weather types are now on their own line. This might seem like a small change, and indeed is an example. It is, but it is an important so. The second change was that I wrote if weather equal to dots, and I didn't try to spell that by what, because Swift knows I'm comparing against the weather type, so it's doing time inference. Now we might try to rewrite the get other method, so switch weather. Now, yes, I realized it was gonna hit. It's like it's hardly a great lyric, but that's academic. So what does it do basically? Okay, so Enum is basically going to, let's do open here. And then now let's say Enum, let's say, yeah, Enum, what is the use of Enum? Enum is a special type in programming used to define a collection of name constants. You can, okay, now let's do that in Swift. Let's scroll down. Okay. Okay, what does it do? Now, key features. Okay, now enum is short for enumeration. Define a type that can have a set of related values. It is similar to enum with added features such as the ability to associate values with enum cases and the defined methods and complete problem. Key features of insert: define a set of related values. Enums allow to define a fixed set of related values that a variable can take. Now, this makes your code more readable and type safe. So, why do we write case in enum? What's the need to mention case over here? Okay, in Swift, the case keyword is used in enum to define the different possible. Okay, so now, so it's saying, so this is saying that this could be on Monday, this could be Tuesday, this could be Wednesday, this could be Thursday, Friday, Saturday, and Sunday. This case keyword is necessary to define each value or state that belongs to the enum. Every possible value that the enum can represent must be defined as a case. Now, does this expect a number? Like, what is this? Is it like a value? No, the case keyword in Swift does not require a number. The case keyword is used to define distinct values. Okay, these are basically the values. So north is a value and not a string. Yes, and north is in an enum like direction is a value, not a string. Okay, so what I'm saying is basically, so I am saying that this direction could have the value north, could have the value east, could have the value south, and could have the value west. These are just names and no numbers are involved. Okay, let's see when north is an enum is a value, not a string. It is an instance of the direction enum, and by default it is not treated as a string unless you specifically define it as well. So let me clarify this. Now, when you define an enum, these are values of the direction enum. So I can say this direction could have the following values. These values are not string but rather instances of the direction enum. Each one represents a distinct state or opinion within the enum. By default, these values are not stored as strings or numbers. They are just identifiers. Okay. For direction dot north is an instance of direction enum, not the string north. You can verify. So when I do direction dot north, Basically this will be an instance. Yeah, when I'm accessing it using dot. So why do we need, so we need to create an instance, right? To create an we use dot. Yes, so like when we do this, we are just defining what all possible is. So when we create an instance, basically is when we are actually specifying, actually allocating memory to it. With the north case, for example, now we are actually, now when I do this, now direction dot north is creating an instance of the direction even with the north case. The correct direction is now an instance of direction with the value north. Mm, this is a little bit confusing. No, wait. So this is the value of the enum. Direction is a value of north, I believe. Now I need to create an instance. When I do this, what value is assigned to current? The value is an instance of the direction enum, specifically the north case. What is it? Let me insert enum cases like is an instance of enum time. The value stored in current direction is not directly a string or number, but a symbolic representation of the enum case. It is an instance of the direction enum that corresponds to north case. Even though you don't say it explicitly, Swift uses the concept of enum value to store information about the case. In the case of direction dot north, Swift internally associates it. This is an enum which has this is a enum which has what do you say, of this is an enum of value direction. This is an enum. Now this direction could have possible cases north, case east, case south, case west. So when I do direction dot north, what is happening to current direction? What's the why switches? Okay. Let's not go. Okay. Whether type, this is what you use in place of string or int in a code line to define the 5 possible cases our enums can be. Convention as they start with the lowercase letters of sun, cloud, etc. is just a closing brace. So what is saying, this can be sun, cloud, rain, wind and snow. Now go back and read the code again because I am about to rewrite it with 2 changes. This is enum weather type. This is case sun, case cloud, case rain, case written case no. The function get its status whether column whether type. I made two changes. First, each of the weather types are now their own line. This might seem like a small change, and indeed in this example it is, but it becomes important. So on the second change, the was that I wrote if weather is equal to sun, but then what is when it does dot sun? What happens? What is that sign like? What does current direction contain? When you declare an enum like direction, a direction now is an instance of direction enum specifically representing the northern current direction holds the enum instance that is associated with the north case, not a primitive like a string or a number. In this case, it is an instance of the enum, but Swift internally associates north with a unique identity within the direction type. I'm not still able to understand. Okay. What is the use of enumerations? I see this direction can have different values, but then what does he mean by this? An instance. What does it look like in memory? What is happening here in memory? So let's use this explanation. Okay, so when I do, so what happens in memory, a block will be created. This is direction, and then this will have the reference to dot north. This will be some value. Okay, and then so when I do this, so what happens is I'll be creating a need to write. Is there any writing? Just paint. So this is going to be this. So when I do this, and then and then I'm going to, this is going to be my weather type, and then let's see, yes, there should be something to select, right? Let's start again. Let's clear all of this. There's a way to clear everything, I don't know. Okay, so this is the block. The text going to be here so that it does not. This is going to be my weather. And then now I will have each cases over here. So this is going to be 1. This is going to be 2. This will have a small, this will be a dot mark. Okay. So basically I'm saying all the possible values that that particular variable can hold is given, right? And this is dot mark. And then this is dot rest. So this is basically the reference. This is the reference of it. Dot mark. If I want to value access this value, then I would have to do something like the dot. Now when I declare it, this memory allocation does not click. When I create the instances, when this allocation happens. Direction dot north creates memory only for direction dot north. Is it not? It's trying to say. When you know it does not create a separate memory allocation, as you might think that it's creating an instance that corresponds to this. Okay, so entire end is memory allocated to entire enum or the types. Memory is allocated to the instance of an enum and its type. When you define direction, it represents the type that can have several. The direction exists in the memory, however, no memory is allocated for specific cases. So in order to allocate specific, so when I type this, only this direction is created, and then this all instances have to be created. Okay. Okay. Now, enums are particularly useful inside switch cage blocks because Swift knows all the values your enum can have, so it can ensure you cover them all. For example, enums are particularly useful inside switch. So he's saying that use enums inside switch case. Now when I do dot now, okay, this is basically an enum, right? So when I do this, I'm creating an instance. So how does switch case work with enum? In switch, in sorry, in, swi- in swi- a switch statement seamlessly work with enums, allowing you to handle each cases of the enum explicitly. Enums are designed to be used because the compiler ensures that all possible cases are handled, but in switch, and I switch compare number to match the case. So in Swift, like it's not mandatory to have a number over here. So what it will do is, so for example, here this is I'm mentioning. Now this is indicating that this is going to uh, match the enum of. Okay, so basically what I'm here is I'm already assigning the instance of direction to north. So then this north will print. Is that so? But then why has written current direction? Okay, so here it's direction dot north, right? But so dot north it does. This is withdraw values. No, wait. Let's go. When I do this, now I have allocated memory for north, right? So this is basically refers to direction dot north, and then this is direction dot north. But how does is dot north mean? What does this identify? But there could be multiple enums written. How does this identify which enum is referring to? How does this work? For example, now I have two enums, right? And then now when I do a switch, also I need to mention the reference. So when I mention the reference over here, it checks. So here it's clear because he is mentioning oh, so this weather type will be a reference pass. That's what he's saying. Will be an instance when I call. So I will mention direct dot north, right? So it indicates that I'm referring to the direction dot north within the such that I am referring to non direction and place north, something like that. Yeah, it explicitly tells switch statement that you're going to refer north case of the direction, so then it will look into the direction, whether type of, and it will match that particular case. Oh, so then yeah, we are switch. So this has to be an instance. So switch, and then besides that we can. Okay, there was a question I had asked. Okay, when I have. Okay. We do not need a number to use a switch statement with enums. You can simply switch directly on the enum cases, like switching off an enum in direction west, north, east, south, west. Then I do, so this basically refers to direction dot north. Okay, so what can be? So while using enum, we need to mention which instance. While using switch with enums, we need to mention the instance. This switch specifically related to that. Okay, so now these are some important points. Okay, so now okay, let's write some conclusions. Okay, so consider enum like a big block which can hold multiple data values and are referenced using this. For example, if I do when you declare the enum, we only create memory for the block enum. Memory is allocated to the is when we create an instance of the case. The way we create an instance is by using name dot case. Okay, so let's write. So right now we only have memory for other type. Perfect. Let's do let data equal to other type dot now. This is initialize memory because variable. Oh, sorry. Now data is basically containing data basically contains a reference to other code which has been allocated some memory. Now using switch case with enums. Using switch case. Now in Swift, it's not mandatory to have a number beside the switch. Number to match that is using enum with which we need to mention the extents beside the switch. So now if I do this will be mention the data parentheses is dot now. Now expected. Okay, this is colon. I'm going to do print. Now in a switch will always tell to have that default case. Here it will there is yeah it will say you have that default thing. Default. Yeah, this is language feature, right? Let's run this, but I shouldn't get hello. See, hello is getting printed. Now enums with additional values. Now one of the most powerful features to Swift is that enums can have values attached to them that you define. To extend an increasingly dubious example a bit further, now I'm going to add a value dot wind case so that we can see how fast wind is. For example, now this is going to store a value that is speed and int. Now you can see the other cases do not enter speed value. I put that just into wind. Now for all real magic suite, let's add extra conditions to the switch case block so that a case will match only those conditions are true. What is doing this? Now enums with additional values. Now what am I doing here? Enums in Swift can have associated values which allow each case of an enum to store additional information. This makes enums what are associated values. Associated values allow you to attach additional information to and now it has an associated value of type int. Like what is the advantage using associated like when I say then where is he passing the speed? He has to pass the speed, right? Was I saying when say what are associated values in Swift? That's why let's understand definition. Associated values are values that you can attach to enum cases. These values allow you to store additional information with each enum cases, make enums more powerful. So each case memory representation. So what's happening in the memory? So right now is associated value. I will internally whatever it is going to store. Okay. Basically using associated value, what am I doing? Okay, so right now when I say there is no value associated, like this is basically a reference. When we do this, and no value. So associating value is like adding a value. Okay, so that means case north has a value uh, distance, which is int. So remember here we are holding two datas. Using two data. Is it like and accessing using a reference? Mhm. No, see, this can have multiple data values. It can be this and this as well. So how to access? Using instance. Am I going to use the instance to access it? How to value access? Oh, then I'm just saying. Okay, so the instance is already matched, right? It's basically current dot direction and then the value. Is it mandatory insert? No, I'm saying is this mandatory? Let distance. Now what is binding? Binding associated. What is binding? Let's see what is binding first. Now binding an associated value in Swift refers to the process of extracting and assigning the value attached to an enum case when pattern match. So using is case a keyword or something? Is case a keyword? First let's see where all we can use cases. Inside pattern matching, conditional matching. Okay. And now first let's not use. Let's first see something about case. The case is the keyword in search used for pattern matching. Now how can we do pattern matching? Pattern matching can be done using if case or using switch or if using guard case. While case also is a pattern matching thing. While case. Okay. Now this is as far as case is concerned where it can be used. Okay. Now let's see. If you want to use the additional data, okay, what is associated types? Let's see. Associated value. By default, enums enum have the capability to carry a value along with the case. To access the value, we need to perform binding. Binding is not mandatory in pattern matching. So what does so basically some memory wise, yeah, I'll be having you can use anything, later where anything. And then now one thing that I was trying to say is memory diagram of binding. So so now see. So your enum, it will have a tag and a payload and an associated value. So this payload is going to associate to the tag, so we need to mention the tag. Then if we do the binding, so if we don't do binding, then it is associated to the tag, right? But then we need to associate it, we need to bind it. Okay, so first let's see what's the difference. The binding the associated value when switch statement is executed, so if we match the enum case and then bind the value to the variable distance. At definition level, what would have is each will be having a tag and a payload. The associated value is 100, that is given as like a payload. So this is the enums direction, and then I have the first case that is not, and then it has a payload. Now see, right now the value is not binded to the variable distance. So right now distance is not assigned, that let where is not assigned. So when we do, then we can bind the value. So binding means creating memory for the let. So without binding, the associated value will be in the payload. Can't we directly access the payload? Can't we directly access? Let's not directly access, right? It's like extracting the. Oh. So basically that value is kind of encapsulated, so we will have to bind it. I see what he's trying to say. Value else will not be able to access it as it is capsulated. Okay. So let's do a recap what we learned. So first we came up with a problem. The problem was, what if we can have multiple possible values for a variable. So what we did is we said let's use enum, which will contain all possible cases that it can be. Then we created using the enum keyword, and then we no case there is a keyword, and where is it used? First is enum for representing all cases. Then after using enum we go for pattern matching. This can be if case, switch, or guard case. I need to have next thing with what we did is we said when we create an instance, is when we allocate memory, and then there is an additional behavior cannot be will be encapsulated to perform binding. Then we can access it. Okay, that's all for today's lecture. See you guys in the next one. Thanks. Bye.